All right, so this example, we're told that a simple random sample, so requirements, regardless of if it's a proportion or a mean, the first requirement is to check and make sure that it's random, right? So we already know that that one's satisfied. It has a size of 80 and mean 7.31. So based on that sentence, are we estimating mu or are we estimating p?
Mu?
Yeah, we're estimating mu. And so the second requirement is that n is greater than 30, right? And so since n is equal to 80, that's true, right? So the first question, technically, so if you were to scroll back up, the first question is which parameter are you testing? And so here we're estimating, not testing. It's important. And we know x bar is equal to 7.31. And it says the population standard deviation is 6.26. So which symbol is that? Is that going to be sigma or S?
Sigma?
Yeah, that's sigma. So sigma equals 6.26. So which calculator function should we use?
Z interval?
Yeah. So you're going to put all of this in. So first it asks for sigma. So sigma is at 6.26. X bar is 7.31. N is equal to 80. So I guess I should move this here. And then the confidence level is 0.99. Calculate. So you should be getting a confidence interval of 4.366 to 10.254. And so we can interpret this one. So for this one, we are 99% confident that, and so here we're not actually told any story. We're literally just given some variables, right? We don't know what the variable it represents actually is. And so I'm just going to say that the population mean is between 4.37 and 10.25. One of the reasons that I rounded these to 2 decimal places in my interpretation was because that's how many decimal places it was given to me with. Quick question. Based on this confidence interval, how could I find the margin of error using the confidence interval itself? So
Would you add both of these together, like the 4.366 and 10.25, divide that by 2, and that would be your in the point something? I forgot what it was called. But then you would take 10.254 and minus what you got, these two divided by 2, and that would be your answer, if I'm correct.
yes, you are very correct. However, you are doing it the long way, because that first number that you want to calculate, you're actually already given that number, and it's the point estimate. And so as like a quick experiment, do what you were saying in your calculator, right? So the first number you said to do is 2.54 plus 4.366 and divide that by 2. And that is what you would do. So see what happens when you do that though.
I get 12.437.
Oh, okay. So you have to be careful with your parentheses. Put that 10.254 and 4.366 in parentheses and then do your division.
Oh, okay.
Yeah.
Oh, I get the same thing as X bar.
Yeah, exactly. So you are correct in how you get the number. You're just doing it a little bit longer than you need to, right? And so, yeah, then what you're going to do, so to find the margin of error, is you take your point estimate. So I'm going to delete this so that I have some room here. But yeah, so you take your point estimate and you can either subtract 4.366 or add or subtract 10.254 minus 7.31. And in either case, you're going to get the same number, and that's your margin of error. So this is E. So let's double check that. 7.31 minus 4.366. It's 2.944. 10.254 minus 7.31. That's, yeah, 2.944. So that's your margin of error. And so that's just another way that you can find margin of error. Remember, it's also z sub c times sigma over the square root of n, where z sub c is the critical value, right? So you would have to find this value here. So yeah, this is the long way. There's also this way. And since everything is pretty much, and honestly, if you're doing the online portion of the final or even your next exam, which is on confidence intervals, right? I don't care which method you use to find E. So keep in mind that you can use the confidence interval that you're given to find the margin of error. You just have to work backwards. But yeah, so any questions about this example before we do this last one here? Okay, so again, this one, yeah, no, it doesn't give us any information about anything. Oh, is there a question? Did I hear something? Okay. But yeah, so we're not actually given any information about the variable again. So we're told that there is a simple random sample of size 25 and mean 17.4. So based on this right now, what are we estimating, mu or p?
P?
Yeah, no, because whenever it says mean of 17.4, which one is that?
Oh, it's me.
Yeah. So here, estimating mu. So yeah, the first requirement is to make sure that it's random. And since we're estimating mu, the second requirement would be that n is greater than 30. Is that true in this case? No, right? So what else am I told though? So this is not true. If that is not true, what else takes care of that second requirement? Because the second requirement is technically that the X bar distribution is normal. And so what else can I just be told about the problem?
If it's just, it says is approximately normally distributed. So if it says if it's normal, then that would check.
Yeah, exactly. Because if it says it's normal, then yeah, you can assume that it's normal, right? And so you can't even assume, you know for sure it's normal. And so here, it doesn't matter that n is not greater than 30 because of that normally distributed. So pay close attention to that. Since we're doing everything online now, it should always say random. So that's never a reason to stop doing a problem. But this might be a reason to stop doing the problem. So if one of these two things is not satisfied, then your answer should be, we can't solve this, right? We can't use the properties of the normal distribution. And so, okay, so let's keep reading the problem and figure out if we're going to use z interval or t interval. And so here I'm going to restart this sentence because this is one of those sentences where you have to read it very carefully. And so it says a simple random sample of size 25 has a mean of that and a standard deviation of 5.3. So is this standard deviation going to represent S or sigma?
S.
Yeah, this is going to be a sample standard deviation, right? And so here we know that S is equal to 5.3. X bar equals that 17.4. And so which calculator function do we want to use?
T interval.
Yeah. And so once you put all of that in, so let's see what happens. So stat tests, T interval, X bar is 17.4. Remember this is SX, right? So this is 5.3. N is 25, confidence level is 0.95, calculate. So the interval that you should get is 15.212 and 19.588. And so to interpret this, we're gonna have, we are 95% confident that the population mean is between 15.2 and 19.6. And then just as another example to show you how to find the margin of error using your confidence interval, you're gonna have 19.588 minus your sample or your point estimate, which is also your sample statistic. So 17.4. And so your margin of error here is gonna be 2.188. So are there any questions about these last two examples that we worked on today?